Web servers and associated threats. Web servers are vulnerable to hacking attacks due to their faulty implementations. An attacker can invade at all levels web servers, OS, and the web applications. But with a good defense system and monitoring tools installed, a web server attack can be countered. In this module, we will learn about web servers' threats and learn about the best techniques and technologies to prevent them. By the end of this module, you will be able to explain the concept of web server and demonstrate its working model, identify various web server attacks and their methodologies, describe the usage of various web server attack tools, understand the concept of patch management and web server pen testing. When a user calls a web page, a request is sent by the computer to the web server. The web server then uses Hypertext Transfer Protocol, HTTP, to respond. All systems or computers that host websites have web server programs installed on them. A web server comes in a pre-built package serving a large number of internet and intranet-related applications, such as emails, uploading and downloading files, and develop, publish web pages. One of the very well-known and widely used web servers is Apache. Others are Microsoft's IIS, Nginx Novell's NetWare Server, Google's GWS, and Domino Server by IBM. Web servers are susceptible to attacks and security breaches. Some of the common issues are SQL injections, cross-site scripting (XSS), broken authentication and session management, insecure direct object references, security misconfiguration, and security misconfiguration cross-site request forgery (CSRF). A web server is incorporated with a modular architecture. This supports many programming languages, APIs, to aid creation of dynamic content or modification. With a client request, a web server responds in one of the following ways. Respond with the requested file from the static database, respond with a suitable message and communicate with the database. A web server can handle multiple client requests simultaneously using the concurrent approach. The following methods help to attain a concurrent approach: multi-processing, multi-threaded, hybrid. The open source server can be used freely on Windows, Linux, and other operating systems. There are many open source web servers. Let us discuss the architecture of the most popular open source web server, Apache HTTP server. The Apache server is based on the LAMP configuration: Linux, Apache, MySQL, PHP. Internet Information Services (IIS) is the web server program developed by Microsoft and is used in web applications related to Microsoft Windows NT 2000 and 2003 platforms. Let's discuss the internals of IIS 6. The IIS architecture is divided into user mode and kernel mode. The user mode consists of all the executing code, like the WAS and the www services. The components of the mode do not have direct access to the hardware or the database, and any crashes or errors can be easily recovered. The kernel mode can access the hardware and a database and execute CPU instructions. Only the most trusted functions of the CPU have kernel mode access, as one fault can crash the entire system. The HTTP sys is present in the kernel mode. Let's discuss HTTP sys in detail next. HTTP sys. Hypertext Transfer Protocol Stack is the HTTP listener implemented as the Kernel Mode device driver. HTTP sys is the main component to receive and serve HTTP requests. When a website is created and deployed using IIS as the web server, the website is registered with HTTP sys by the IIS. These services are carried out by the HTTP sys in IIS 6. It accepts the HTTP requests and routes it to the correct user mode request queue. It performs caching of the HTTP responses and sends it to the client. All the text-based login is done by HTTP sys for www service. It helps in implementing and maintaining quality of service, QoS, which includes optimizing connection limits, queue length limits, connection timeouts, and bandwidth throttling. There are various services available by Internet users all the time. This data exchange and transactions make the web servers vulnerable to attacks from hackers, intruders, and attackers. Let us look at some of the common web servers attacks that can be encountered. Dns Server Hijacking. In this attack, the attacker changes the DNS configuration settings and diverts the requests from the target server to his own server. All this is done without even touching the target website. DNS Amplification Attack. This is a popular form of DDoS attack. The attacker sends a DNS lookup request to an unguarded DNS server using imitated target IP address. So when the DNS server sends the DNS record response, it is sent instead to the target. Since the responses could be large files, a huge network traffic can be created. DOS/DDoS attacks. Denial of service DOS, distributed denial of service DDoS. Attacks make the server unavailable to the users and ultimately cause it to crash. In these attacks, the server is sent many fake requests. The traffic on that network increases and the system overloads. This prevents all the genuine users' requests to be fulfilled. Man-in-the-middle sniffing attack. In this attack, the session ID is hijacked and the attacker poses as the user. The attacker accesses the user information and can misuse it. The attacker can also hijack the entire session and pretend to be another party in session, which will give access to both the user and the server's information and is called man-in-the-middle. Phishing attack. This is a very dangerous attack. Here, the attacker disguises himself as the original website and tricks the user into entering sensitive information. Web cache poisoning attack. In this attack, the cache repository of web server is forced to remove its original cache content. The attacker then replaces the original content with the spoofed cache content by sending a crafted request. SSH brute force attack. In this attack, the passwords and accounts are compromised by using automated programs to try thousands of username and password combinations. To prevent the account from getting locked by maximum fail attempts, the hacker tests the same username and password combinations on many systems, thereby increasing the chances of finding the right password. Web server password cracking. In this attack, the attacker tries to guess the password by entering all possible and most frequent passwords. This attack is usually performed on weak passwords, such as admin password, own name, etc. There are various manual methods, dictionary attack techniques, and automated tools to crack a password. Web application attacks. Attacks on the web applications can cause risk to the web servers. Some of the risks are parameter form tampering, cookie tampering, invalidated input and file injection attacks, SQL injection attack, session hijacking, directory traversal, denial of service attack, cross-site scripting attack, buffer overflow attack, cross-site request forgery CRSF attack, In this section, we will learn the common attack methodologies used in ethical hacking. In information gathering, the target information is collected through tools like WHOIS, traceroute, ActiveWHOIS, etc. Queries to the WHOIS database and the robots.txt file can reveal the IP address, domain name, databases and root directory structures, etc. In web server footprinting system-level data, like OS details, account details, software versions, database schema, and server names are fetched using various tools such as HTTP Reckon, ID Serve, Netcraft, etc. Mirroring a website creates a complete replica of the site's directory structure. Its file structure, including the external links. Tools such as Web Copier Pro, httrack, Black Widow, etc. can be used to achieve this. Vulnerability scanning is performed to detect and identify any bugs or weaknesses that can be exploited by an attacker. Various tools such as Acunetics Web Vulnerability Scanner, HP Web Inspect, etc. can perform the scanning and vulnerability detection. Session hijacking is attacking the user sessions through a protected network. Tools like Barb, Sweet, G-Hijack, Firesheep can be used. Various methods can be used to hack in web passwords. Some of the popular methods are dictionary attack, brute force attack, password guessing hybrid attack. The attackers have now adopted several web server tools to help them succeed. The web server attack tools are used to generate and test exploit code and find any weakness. They are intended to attack the server to gain access to the resource or account. The two popular web server attack tools are Metasploit, Framework, MSF, and Fetch. Let us learn in detail about these two tools. Metasploit, Framework, MSF, is regarded as a freely available best auditing tool. It has features like exploit development, environment, commercial-grade exploits, complete information gathering tools, and plugins for monitoring web vulnerabilities. The MSF architecture is divided into main modules of Exploit module, Payload module, Auxiliary module, and NOPS module. Let's discuss each module. Exploit module is the basic module of Metasploit, which encapsulates an exploit to target multiple platforms. Follow these steps to exploit a system under Metasploit framework. Configure inactive exploit. Exploit options verification is done. Choose a target. Choose the payload. Finally, launch the exploit. Payload module medium to establish a communication channel between the victim host and the Metasploit framework. A code is generated when the exploit succeeds. The payload module combines this code that runs remotely. Auxiliary module is mainly used in penetration tests. There are numerous arbitrary one-off actions like denial of service, fuzzing, and port scanning that are performed by auxiliary modules. The exploit command or run command is used to run the auxiliary module. NOPS module generates the no operation instructions. These instructions are used to block out the buffers. Examples of how an arbitrary size NOP sled is generated using the generate command is shown in the image. A 50 bytes long NOP sled can be generated using the generate command as shown in the next image. WFetch is a user-friendly interface originally designed to resolve issues in Microsoft's IIS web server. It helps to reproduce issues of the test environment and resolve it completely. It supports granular testing approach down to authentication and authorization level, custom headers, etc. It is equipped with various authentication and connection features. Web functions such as get, put, trace, head, and post help to run WFetch. As in the figure, enter one of these functions and press Go. The output is displayed in the log outputs. Hackers access critical details of users by gaining access to the user's email account or applications. The best security measure is to protect devices, applications, and accounts with passwords. Normally, hackers try with a number of possible password combinations, but they also use few web password cracking tools, which help to recover passwords quickly and easily. Web password cracking tools are specially designed utilities that uses several algorithms and web server attack. The two popular web password cracking tools are Dns Hijacking and Brutus. Now let us see how these tools help to recover passwords. Dns Hijacking is a well-known free password cracking tool. The tool uses brute force or dictionary attacks to crack passwords. It is indeed a very stable and quick network login hacking tool. To crack the login credentials, quick combinations of alphanumeric characters are used. Dns Hijacking also helps monitor and check the security aspects of a web server and its vulnerability to gain illegal access from a remote location. Hijacking is compatible with Linux, QNX, BlackBerry 10, Solaris, Windows, Cygwin, OS X, FreeBSD, OpenBSD. The tool is also compatible with several protocols and is used as a parallelized login cracker. It allows easy and unauthorized access to any system remotely. Brutus is another free and highly popular password cracking. Brutus is compatible with only Windows 9X, 2000, and NT. It does not support Unix and Linux platforms. The primary goal was to check routers for default or common passwords. Since its inception, it has become very popular and the download count crossed 70,000 to 1.6 million visitors. New releases with more advanced features are being introduced frequently. Web servers should be placed in a separate secure server security segment on the network. There are 3 security segments designed for an ideal web-hosted server. These are Internet Segment, Internal Network and Demilitarized Zone (DMZ), or Secure Server Security Segment. Keep the web server in the DMZ segment isolated from public network and internal network, as all the traffic directed towards DMZ should be intercepted by the firewall. A series of services are provided by the web servers over the Internet, which makes the web server susceptible to attacks, hacks, and information thefts. Hence, it is very important to take certain preventive measures in order to protect the system from various web server attacks. Proper maintenance, security, and testing is required to safeguard the server. Let us discuss the countermeasures that can be taken to protect web server. Patches and updates, protocols, accounts, files, and directories. Use website change detection system to detect any attempt to hack the web server. How does it help? A specific script is run on the server to detect and monitor any new file that is uploaded to the server or any existing executable file is modified. Frequent comparison of the hash values with the existing code base hash is done to detect any possible change in the server files. Any change detected on the server is reported to the user immediately through email. Let us go through a quick list of actions to defend against web server attacks. Keep your web server on a dedicated machine. Cautiously create URL mappings to the internal servers. Do not install the IIS server on the domain controller. Use server-side session ID for tracking and match connection status with the IP address, timestamps, and so on. Install the database server Microsoft SQL, MySQL, on a separate server. Secure your web server by enabling all the security features available within the web server along with the automation of the scanners. Keep the server in a highly secured place to defend against physical vulnerabilities. Before connecting the IIS server with the internet, make sure that it is fully hardened. Do not provide access to login to the server other than the administrator. In case of multiple web applications, provide individual accounts for users. Verify the compatibility of the server to web technologies to be used in applications. Screen and filter incoming traffic requests. HTTP response splitting is a web application vulnerability which occurs when an application or its environment has failed to sanitize the provided input. Web cache poisoning occurs when the web content in the cache is replaced with spoofed content. Let's go through the defined measures. Server admin. Use the latest and updated web server software for server admin. Keep the OS and web server up to date by applying patches or fixes regularly. Regularly run the web vulnerability scanner. Application developers. Restrict access to the unique IPs for web applications. Do not allow characters such as line feed and carriage return. Ensure HTTP 1.1 is compliant with RFC 2616. Proxy servers. Do not share incoming TCP connections with other clients. Use individual TCP connections for different virtual hosts. Also, ensure appropriate implementation of maintain request host header. DNS hijacking occurs when the queries are redirected by an individual to a domain name server, DNS. Harmful software and unauthorized server modifications are used to hijack DNS. It is critical to prevent this attack. Follow these measures for defending against DNS hijacking. Place a registrar lock on a domain name using the ICANN accredited register. Ensure if the registrant's account information is safe and secure. Include DNS hijacking in the business plan and incident response. Regularly monitor DNS server IP address using DNS monitoring tools services and alert him in case of any issue. Do not download any multimedia file or codecs from untrusted websites. Install an antivirus program on the server and update it regularly. Change all the default passwords before deployment. Use the UDP source port randomization technique to fight against blind response forgery. Increase the TTL of legitimate records and impose a limit imposed on the simultaneous recursive queries. DNSSEC, Domain Name System Security Extensions. Establish strong user management and password policies. Give the service level agreements from DNS service provider. Configure your network with a master slave as recommended. Monitor the DNS servers constantly. Patch management makes it simple and easy to acquire patches, install, and test them. It helps to keep a system updated on all security patches available and determine which patch should be used or which should not be used. Since its inception, patches have evolved into new forms. Initially, patches were shared through external media devices as individual standalone code modules based on traditional free licensing systems. Today, in this digital era, patches are applied to the programs over a global IP. Patches are added to software and updated automatically. The procedure to identify suitable source for updates and patches include: prepare a patch management plan that suits your business and operational environment. Look for suitable updates and patches on the official websites of the vendors or the home website of applications. Register on the application websites to receive alerts on related issues. You can install security patches either manually or automatically. For manual installation, download the security patch from the vendor website, whereas for automated installation, applications use the auto-update feature. Now, let us understand the implementation and verification procedures of installed patches. What are the steps to verify a patch? Verify the source before installing a patch. Create a good patch management plan to validate checksums and file versions prior to deploying security patches. Monitor the patch systems with the help of patch management tools. Patches and updates must be regularly verified. What are the steps to implement a patch management? Security and patch information sources, automatic system discovery, prioritization and scheduling, testing, change management, installation and deployment, audit and assessment, consistency and compliance. Let us have a detailed look on implementing a patch management system in the next few slides. Security and patch information sources. The IT administrator must monitor the security issues along with software updates, patches suitable for their environment. Automatic system discovery. Komodo scans the systems and discovers updates for Linux and Windows systems using Active Directory systems to deliver the intelligence for obtaining real-time analysis of the network. Prioritization and scheduling. The tools are categorized based on vendor, type, or severity, which helps to prioritize patch deployments. Schedule the critical security patches daily and completely. Automate it and other non-critical patches as needed. Audit and assessment. Use global patch inventory to track all applications and then apply all patches in real time. You can also generate status reports and assessment of network. Testing. Validate the patches before installation. Install them in a test environment to check their effectiveness. You can either install them as a single patch or in bulk before finally approving or disapproving. Change management. Use Komodo One platform to monitor all changes made by the patches, along with the network status. You can generate reports and keep track of missing and applied patches and also monitor successful patches. Installation and deployment. Komodo One real-time status report is based on the difference between the endpoint of the old patch and the latest patch. The deployment of patch depends either on demand or by way of policy, resulting in a fast and efficient process. Consistency and compliance. With Komodo One, you stay compliant with the entire network. There are various patch management tools to manage such patches. The most popular is the Microsoft Baseline Security Analyzer, MBSA. Let us have a detailed look at this tool. Specially designed for administrators, MBSA scans the system for any security misconfigurations and missing security updates. This tool can be used in small to medium-scale organizations to evaluate the security state and recommends enhancing the security management system of the organization. There are various patch management tools to manage such patches. Features of MBSA include Command Line Tool, Windows Embedded Support, supports local and remote scans, Graphical User Interface, scanning of multiple instances of SQL servers. Other popular tools include Altiris Client Management Suite, Security Manager Plus, Secunia CSI, Prime Suite, VMware vCenter Protect, ZenWorks Patch Management, GFI LandGuard, Kaseya Security Patch, Mass 360 Patch Analyzer Tool, Limusion Patch and Remediation. Web server security deals with securing data and information access through web server. This is critical along with securing websites, applications, and system data. There are several web server security tools such as Web Application Security Scanners, SciHunt Dynamic, NStalker Web Application Security Scanner, Web Server Security Scanners WIGTO, Acunetics Web Vulnerability Scanner, Web Server Malware Infection Monitoring Tool, Hack Alert, Qualys Guard Malware Detection. SciHunt Dynamic. Let us have a look at the functions of the tool in detail. SciHunt Dynamic tool helps to fix security vulnerabilities with minimal effort. With incredible features, the tool is easy and simple to understand and manage. Just type the URL and press Enter for all required information. It includes Deep Crawler, Advanced Injector, Code Analysis Extensions, scan any kind of web environment. The NStalker Web Application Security Scanner helps to identify vulnerabilities in a web over the application and the infrastructure layers, based on Top 10 Open Web Application Security Project (OWASP) and Top 25 Common Weakness Enumeration (CWE), respectively. The infrastructure layer is scanned against more than 35,000 signatures for third-party packages and server. WIGTO is a web scanner working between the application and the network layers. The tool is neither a web application server nor a network-level scanner. It does not identify an application and its source, any open ports or issues related to firewall. It primarily identifies the files which are vulnerable to the web server and its implementation. The scanner drastically reduces the occurrence of false positives by applying fuzzy logic on the received responses. Functioning is similar to backend miner. It can import directories from Googler and backend miner. Acunetics is highly advanced and improved scanner, which can easily prevent hacking attempts on systems. Firewalls, security certificates, and other lockdown servers do not guarantee a secure application, but Acunetics provides safety and protection. Hack Alerts is a unique cloud-based monitoring tool, which identifies hidden malware in websites and online advertisements. It works from day zero. The tool can be activated using the domain name. It triggers an alert on identifying a suspicious activity before Google takes any action and saves the website from getting blacklisted. Knowing in advance helps to safeguard a database and other accounts, and then take a remedial measure. Testing the performance of web server administrator to verify if it is an upright web server admin is critical. There are several criteria to do it. One way is to measure by counting the number of web servers supported in a day, malicious attempts in statistics, or the total uptime measure. Second, web server penetration testing is done to locate, identify, and report vulnerabilities associated with authentication configuration related to protocol, and so on. How do the penetration testing? Gather information on the physical location of the OS environment, website target details, contact information, and server information using the WHOIS database query tools, or footprinting, reconnaissance, and website crawling. Use directory traversal attack commands to gain access to restricted directories. Use tools such as Nessus, HP, Web Inspect to check the vulnerabilities in a system. Do a web cache poisoning attack by sending a specially crafted request to be stored by the cache. Get the credentials of FTP and brute force SSH to gain unauthorized access. Use Hamster, Burp Suite, and Firesheep to perform session hijack. Use tools such as AWStats, Webalizer, KT-Matu, Relax to examine web server logs. Use tools such as Metasploit, W3F to exploit frameworks. Use man-in-the-middle attack to intercept sensitive information. Hack web applications to gain information. The web server pen testing tools are used to report, analyze, and identify weaknesses such as configuration issues, authentication vulnerabilities, and protocol accessibilities. The common web server pen testing tools include Core Impact Pro, Immunity Canvas, Arachne Core Impact Pro 8, which is a powerful and most popular tool in vulnerability assessment and penetration testing software. It is backed by its unique and most advanced features and modules. Immunity Canvas provides several automated and efficient exploits. This tool is utilized by security professionals and penetration testers and is highly adaptable due to its open design and suits most requirements and environments. It can be used on Windows, Mac OS X, Linux, and Python environments. Arachne is a free, high-performance Ruby framework, specially designed for administrators and penetration testers. This open-source and modular framework is used for checking the web application security. It can be used on Windows, Mac OS X, Linux, and Python environments, and supports highly complicated web applications due to its integrated browser environment. Check your progress so far. You have learned about web servers and associated threats. Let's check your understanding of this module. The process of imitating a website and then tricking the user to enter his login details is referred to as. The answer is phishing attack. Which module of Metasploit establishes a channel between the Metasploit framework and victim hosts? The answer is auxiliary module. In which attack DNS configuration settings are changed by the attacker? The answer is Dns Server Hijacking, which changes the DNS configuration settings. A small piece of software designed for fixing existing security issues of any application or operation system is referred to as. The answer is patch. This concludes the web servers and associated threats. Let's take a minute to review the key points you have learned in this module. I will pause for a few seconds to allow you to read it. In the next module, we will learn about web applications and associated threats. Thank you.